Hello everyone, I am Kukenda Narayansamy, matrix number CE200-12. This is microprocessor and microcontroller assignment. So I am from group 2 in section 2. So I will be explaining the program code in order to perform this assignment. So you can see here, I have enabled the interrupt function. So this will be port 0 and the pin 11 will be enabled. So later on when I want to reset, I will be using this pin 11. And also I have initialized the input output ports here, which is port 0, 1 and 2. And then I have initialized the ADC. So we can see here I am enabling port 0.23 and port 0.24 as for my sensor 1 and sensor 2 respectively. So in order to enable AD0.0 and AD0.1, so I need to enable pin 14 and 16. So I have enabled here. So this is according to the user manual. For pin cell 1, you can see here for port 0.23 and 0.24, it is the function for AD0.0 and AD0.1. The function when 0, 1, which is this must be 0 and here this must be 1. So 14 and 16 must be enabled in order to use these ports. So I have done my coding here. So next I have to initialize the PWM, which is a pulse width modulation. So same, you have to refer to this pin cell 4. Here I have enabled 6 and 8 because I am going to use PWM 1.4 and 1.5. So according to this user manual for pin cell 4, since I am using port 2.3 and 2.4, PWM and 1.4 and PWM 1.5, the function when 0, 1. So 0, 1. So for port 2.3 and 2.4, the 6 and 8 must be 1 must be enabled. So that I have done in my coding here. And this PCR is also for 6 and 8, it must be 12 and 13 must be enabled. And this is the PWM cycle, which is 100 microsecond, and it is for MR0 as well. Since I am using 1.4 and 1.5, PWM 1.4 and PWM 1.5, I will be using MR4 and MR5, and I have disabled here. So later on I will be adjusting the value using the AD converter tab. And next will be, okay, this is the 8-bit binary counter which is for the LED. So it will be 0 until 7 for 8 LEDs, and I equals to I plus 1, which means the counter will be increasing one by one. This is for the enabling and disabling the motors. EN1 and P1.0 represents the motor 1, and P1.1 and EN2 represents the motor 2. So you can see here, if the result 1 is equals to 0 and result 2 is also equals to 0, which means motor 1 and motor 2, the sensors are equals to 0, then it will be, the motor will not be spinning. You can see here it is 0 and 0. If 0 and 1, which means 0 is for 1.0, which is motor 1. If it is equals to 0 and motor 2 is enabled, which is returned to 1. If more than 0, motor 2 is more than 0, then motor 2 will be enabled. And if 1.0 is motor 1, the result 1 is more than 0 and result 2 is equals to 0, then motor 1 will be spinning, motor 1 will be enabled. If both of them are enabled, which is more than 0 and 1, 1, you can see here, then both of the motor will be spinning. Once done, then this is the delay function. So once done with the code, you have to compile to check for errors. You can see here it is 0 errors and 0 warnings. Now we can continue with our debug session. Okay, so now this is the AD converter, and this is the general purpose GPIO port 0 and pass interface step. and this can be opened using these peripherals, the AD converter, and also GPIO bus interface and port 0. So next, this is the logic analyzer, which can be opened using view and analysis window. So in logic analyzer, now we have to set the port. So click on setup. So here I have already set the port. It is for port 0. This is to reset and to check the LEDs from 0 to 7. It is for 8 LEDs. And next is for port 2.3, and also this is 2.4 and 1.0 and 1.1. The 1.0 is for the Moto 1 and 1.1 is for Moto 2. And 2.3 and 2.4 is where we can get the output. It is Moto 1 and Moto 2 respectively. So here we can check for the duty cycle, and we can change the value of the duty cycle in order to control the speed of the motor. So once done, we have to close. We can run this code to check the output. So now it is running. So you can see the counter has started. So 0, 1, 2, 3, now it is increasing one by one. To reset, click on pin 11. Since in the code we have set to pin 11. So once we click reset, you can see it has been reset and starts again from 0 and increasing one by one. And we can see here the LED will change, and for the pin 6 we can see 0, 1, 1, 0. For pin 7, 0, 1, 1, 1. So it is basically showing us in binary form, because each one of it is 1 bit, represents a bit, and all of them can be used as a binary. So next step is to check for the output in 2.3 by enabling we can put the value in AIN0, AIN1, which is for Moto 1. And now we have enabled the Moto 1 here, so we can see the result here. So we can see the result 2.3 and also 1.1. It is now enabled, whereas Moto 2 is not enabled yet. So now we are going to enable Moto 2 as well. Let us put 0.3. So what am I doing here is enter the temperature value, which is must be before 3.3 volt, the reference voltage. And you can see that in 2.4 and also Moto 2 it has been enabled 1 and 1. So if we zoom, you can see that the duty cycle for Moto 1 is much more smaller than compared to the Moto 2. This is because the value is actually smaller than Moto 2 here. And if we change the value to a higher value than Moto 2, let's say 0.4, you can see the result here. So you can see here, now the Moto 1 duty cycle is much more bigger than this Moto 2 since we changed the value. So basically this is the analog input we are going to use we are using, because we are entering the temperature value. Now this will be converted to digital here. You can observe the value in result 0 and result 1. So basically what we can conclude here is as the temperature increase, the voltage value in the temperature sensor also increase, and also since the speed of DC motor proportional to this temperature. Since if temperature increases, the speed of DC motor also increases, and if the temperature increase, we can see that the duty cycle also become larger. Let's for example here, this is for the Moto 1. We can see that it is 0.4, which is more than this Moto 2, which is 0.3. The duty cycle is much more bigger than this Moto 2, which means if the duty cycle getting bigger, then it is reducing the rest time. Since the temperature increases, the duty cycle also increases. And also which means from here we can conclude that the DC motor is also proportional to this duty cycle as well. If the duty cycle increases, the speed of DC motor also increases because the rest time has been reduced. So for example, we can see here, if we put 0.8 for example, so we can see here that you can see the duty cycle has increased and it has the rest time also reduced. So that's all from me. Thank you.